So this is going to get, so this is where we start really getting into describing acceleration and understanding, because it sounds simple. I mean, I think we're appreciating that acceleration. I mean, it's been a great discussion. Talking about circular motion is helping, I think, some of you understand this idea of velocity as having direction, and that acceleration means a change in velocity, which sometimes can just mean a change in direction of an object rather than a change in its speed. But all sorts of things are happening in this particular example that we did, tossing the ball. So the first question, so this is where we have to be careful in describing this, and I have to be careful. I'm learning, I mean, one of the things that I'm sure you appreciate is I'm learning a lot as we go here too, and how to talk about this. This next part is going to be challenging. Let's talk about acceleration. What direction is the acceleration? Let's talk about these different points. So let's get to this. So we have point 1, 2, 3, and 4. Now, point 1 can be interpreted a bunch of different ways, because it kind of depends on whether you're still holding the ball before or after the release. So maybe let's take the before the release case. So you're still holding the ball. So let's talk about these different questions. So actually, if we are talking about before the release, it's the most complicated one of all. Let's work with that. So what's happening before the release? What are the forces on the object? A hand and a push is a good way of describing it. It's a push by the hand. And there was another force that was mentioned. Yeah? Now gravity. We can talk about gravity. It's okay. This is a gravity-friendly discussion. All right. So in point 1, we have a push upward and a force downward from gravity. Okay. What direction? So this, again, this is the most complicated. Let's just, number 1 does not belong. It's not like the others. Let's just talk about 1, and then we'll talk about the others. So what direction is the acceleration at point 1?
Up. In the same direction as
V sub I equals zero.
What's that?
It's the initial velocity. Are we at rest still?
So that's a good question. Yeah, right here. No, we're not. But halfway up.
As soon as you release.
I think you can answer this a bunch of different ways, but I think the acceleration has to be up at some point here, right? We're going to be moving from stop to moving upward. So the change in velocity is in the upward direction. So we do have an acceleration upward. Let me say that again, because that's crucial for you to understand how to choose directions here. The change in velocity is upward. Does everybody understand what I mean by that? When I apply direction? Yes, ma'am.
So technically, though, don't you have to talk about changing from one point to another point? Because if you point
Absolutely.
at one point, there is no change at one point.
Absolutely. Well, this is where, well, unless you use calculus, but we're not going to do that.
Thank you.
Okay. That's what a derivative. That's precisely what a derivative is figuring out a change, an instantaneous, what the change is. But yes, you're absolutely right. The way you always want to think about if you want to think about acceleration, it's a change. So let me write this down in a little bit more sophisticated way. Acceleration is equal to v final minus v initial over t final minus t initial. In other words, the velocity at the end point, you've got to choose 2 points. The velocity at the end minus the velocity at the beginning, the time at the end minus the time at the beginning. Does that answer your question? So you do have to choose 2 points at time to define any of these properties. If this is confusing, please don't.
Because that's the problem we got into when we were talking about 3. Position 3.
Okay, we'll get to that. So at point 1, right, what direction of the force? I think we already talked about that. Right, okay, so you guys are saying upward. There's more than one force though, right? So you're saying something about the net force, I think. The net force is upward. Okay. All right, point 2. This is where things are going to get a little sketchy, I think. All right, here's what I'm going to do. I hope, again, this doesn't get too confusing. Oh, that's great. That's great. Let's move forward. All right, so this is the ground. So I'm going to do something that we always have to do in physics if you're going to do a problem, if you're really going to do a problem mathematically. And I know that we're not sitting down and doing physics problems the way you know, we would in an introductory physics class. But one of the things we first do is you have to define what direction is up or which direction is positive. In other words, this is moving in a positive direction, or this is positive velocity. You understand what I'm saying? So we're defining upward as the positive direction and downward as the negative direction. That makes sense? Mm-hmm. Okay. So that's what. So we're going to talk about the directions of all of the acceleration. So in the first case, number 2. All right. So what direction at point 2? What's the direction of the velocity? The velocity. What's the direction of the velocity? Okay. And it's positive. It's up, which is what we're calling positive. All right. Now comes the tough one. What direction is the acceleration? No, it's not in the hand. Okay, so there's some people saying negative. It's in the negative. The acceleration is downward. The acceleration is downward. Now that may be blowing some of your minds, but let's think about that for a second. Does anybody disagree with that? It's all right. Sometimes you got to stand for what you believe in. What do you?
A net. What's the acceleration going up? Have to overcome gravitational acceleration to keep moving up.
So here's what you want to think about. No. I mean, this question is coming up again and again in different areas, and this is great because we're trying to root out something here. You want to think about the ball. Once it leaves your hand, what's continuing to move it upward is inertia, not a force. The forces are so this is what I think we're discovering tonight. Is this idea of inertia is actually pretty hard to get our hands around. It acts against forces. It is the the arch enemy of force. It's not really the arch enemy, but it requires forces to change this thing's state of motion. So when you let go, it's going to keep going up, and even though all the forces may be in the opposite direction, it will keep moving upward. You have a question?
Yeah, because it has gained the momentum,
Yeah, it's got momentum. That's right. Momentum is a whole other concept, but it's related to inertia. We were talking about momentum. All momentum is mass times velocity. That's all that momentum is. But we'll talk. That's a whole other subject we can get into later in a different session about conservation of momentum, which is a lot of fun. So we're talking. So are we?
all the forces.
All right. So we've had some answers that the acceleration is in the negative direction. Is everybody happy with that?
No. If acceleration is velocity over time, how can it go in the opposite direction the velocity is going?
Okay. Wonderful question. You couldn't have asked a better. That's exactly what that's something I was planning on asking. Can the acceleration be in the opposite direction of the velocity? Remember, so that's why it's good that I wrote it this way.
Oh, because the initial and the minus, so the initial and the minus. Okay.
So this can be negative. Your final velocity can be less than your initial velocity.
Okay.
So if you're slowing down, This is simple as this. Simple as this. If you're slowing down, your acceleration is in the opposite direction of your velocity. That make sense? Now, it's what you call decelerating. I mean, that's what it's what we call deceleration. And I think we want to be careful. We either got to use a negative sign or use deceleration. And you don't want to use both because then we'll get really confused. So we'll call it negative acceleration rather than deceleration. So yeah, so if that helps you, we're called an acceleration in the opposite direction of velocity is what you would commonly think of as deceleration. So another way of looking at this is you've got one way of thinking about an object that's got a force on it, it's moving and it's got a force on it. Is it's got you want to think of you might want to think of the velocity. It's got a bank account. It's got a certain velocity, and if it's got a force on it, that force is going to be pulling velocity, a certain amount of velocity per second out of that bank account. All right, that's what's hard to that's the part of this that is very uniform. Although this motion doesn't look that uniform, what is happening every second that's exactly the same is the velocity is changing the same amount every second. Okay, it's getting more and more downward. All right, so let's talk about point 3. What's happening in point 3? What direction is the acceleration? Right. Yeah. Right. So. Yeah. So, does anybody? So, what is the answer? This is a good question that we'll get to. So, I've got an answer this way.
We said 0.
Yeah, I mean, even let's just talk about it straight up. Any other answers?
I said 0 acceleration.
Is its velocity changing? Is its velocity changing over time?
Well,
In what direction?
going opposite.
What's the net change in velocity? Which direction is the net change in velocity? Down. So what direction is the acceleration?
Down.
So it turns out the acceleration is precisely the same here as it was in 2. Is that hard to get your hand around?
No.
Get your head around?
Yes.
Yes.
But
now
a
the
second
velocity
before
is
that?
different.
Wait a minute. A second after that is changing?
That's mind-blowing.
The acceleration.
So the way you want to think about acceleration is a change in velocity over a change in time, right? And a very good point was brought up here. It's hard to talk about, and it's the same point that you were making. We talk about it in a snapshot of time, right? It actually, we really need to think about. We need to think about a change in velocity between here and between here and here. What's the acceleration between this point and this point? So for a little small change, for that little interval of time, the velocity. So one thing we haven't talked about is gravity. There is a particular acceleration of gravity. Some people may be familiar with this. It's 9.8 meters per second squared. It's 32.2 feet per second squared. So well, let's keep going. So we'll talk about that in a second. So what those numbers I was just giving you,